Hello and welcome to today's class. We have a radical challenge here. This equation is a simple one, it's an easy one if only you are familiar with the rules that governs indices. So we're going to make use of some of the simple rules that actually guide the operation in indices here. So the question is the square root of, under it we have your 3 to the power of x all further raised to the power of 2 equal to 3 to the power of root x. What is the value of x here? How many values or solution we're going to get from this challenge? Okay, so let's take a solution and see what this gives us in turn. So we have solution. Okay, the first thing we're going to do here is to rewrite the radicals we have here. The one on the left hand side and that at the right hand side. And so rewriting this is going to give us a 3 to the power of x all raised to the power of 2 or in bracket raised to 1 all over 2. This is equal to our 3 to the power of our x raised to 1 all over 2. So we succeeded in eliminating the radical we have here now. Okay, so what we do here, if you take a look at this expression, we can use it to multiply this, right? Good. We are applying the law, or the first law of we're going to operate here with is your a to the power of m times n. This is equal to a to the power of your m in bracket then raised to n. So if we do that, this will multiply this expression we have here. So this is going to give us our 3 to the power of our x all raised to the power of 2 all over 2. This is equal to our 3 to the power of x raised to 1 all over 2. If you check the base numbers, they are the same. That on the left hand side and that on the right hand side, they are both the same. And so it means we can equate the exponents, right? So if we equate this is going to give us here our x to the power of 2 all over 2 equal to our x to the power of 1 all over 2. Easy. But we're still having a fraction on the left hand side of the equation. So we eliminate the fraction by multiply with this, which is 2. So this gives us here our x to the power of 2 all over 2 times 2 equal to our x to the power of 1 all over 2 times 2. This and this will leave. So we are now left with x to the power of 2 is equal to 2 into x to the power of 1 all over 2. Wow. So let's check out what this comes out with. Now, look at this power here. And look at this. This is another form of a radical, right? Good. So we have to eliminate this radical again. But we have to take the opposite of this, which is the square. So let's square this side of the equation and this side of the equation. So if we square both sides of the equation, meaning we're raising this to the power of 2, we're also raising this to the power of 2. So with this, we can use this to open up this according to this law. So this is going to give us our x to the power of 4 equal to, if we use this to multiply this, what happened? These two will go with these two. So we are now left here with our x here. And again, these two will affect these two here to give us 4. So we're going to have here 4x, right? Good. So yeah, we move this quantity to this side. I've said this in many of my videos that when you have an expression of this kind, never you cancel out x or never you divide by x. And so we move this quantity on the right hand side to the left hand side. So this is going to give us x to the power of 4 minus 4x is equal to 0. We cannot factor out x here. So if we factor out x, it's going to give us x to the power of 3. It will be 3 rather. So reduce to 3, then minus 4 plus bracket equal to. So from here, we just have to consider the zero property, which says that our a, okay, let's use a times our b is equal to 0, and our a will give us 0, or our b will be equal to 0. So yeah, we're taking case 1, we're going to have x1 is equal to 0. So this is the first root, or the first answer to this challenge. But let's check if this will satisfy the original equation. If I put in 0 here, 0 to the power of 2 will give us 0. So 3 to the power of 0 will give us 1. And square root of 1 will give us 1. And so if I put in 0 here also, the square root of 0 will give us 0. Then 3 to the power of 0 will give us 1. And so 0 is a root that satisfies the original equation. Now let's go ahead and solve for this. This is where we have an interesting mathematics or interesting expression. Okay, now if we decide to move this to this side, I will take the cube root of both sides. We're going to come up with just one root. But here we are expected to look for 3 roots. And so what do we do? If we decide to write this as 2 to the power of 2, that will give us a power of 2. And here we are having a power of 3. And so there is no correlation between the power of 3 here and that of 2 here, as far as this expression is concerned. So we try to rewrite this to the power of 3. And how do we achieve that? We raise the power of this very guy here to the 1. Although we have divisible 1 here. And so rewriting that one, we go to say 3 all over 3. So we're going to rewrite this as our s to the power of 3 minus our 4 to the power of our 3 all over 3 equal to 0. If we consider this property, then we can shift in this 1 all over 3 inside here, right? So if we do that, this is going to give us our s to the power of 3 minus our 4 all raised to 1 all over 3 all raised to power 3 equal to 0. Wow. So with this, what we do, we now have what we call our difference of 2 cubes. So it says that when you have your x, okay, so let's use a, we have your a to the power of 3 minus b to the power of 3. This is equal to a minus b, or in bracket, your a squared plus your ab plus your b squared. So if we rewrite this in that format, we're going to have here bracket open x minus 4 to the power of 1 all over 3 close bracket, our x to the power of 2, then plus, we're going to have 4 to the power of 1 all over 3, then x of x, then plus our 4 to the power of 1 all over 3, all raised to the power of 2. Everything equal to 0 here. Okay, so we're going to have another case here now. So we have case 2. So our case 2, we're taking our x minus 4 to the power of 1 all over 3 equal to 0. So we now have our x2 is equal to 4 to the power of 1 all over 3. Now we can reduce this base here. In other words, we can write this as 2 to the power of 2 and use the 2 as the power to multiply the exponent here. And so we're going to have this to be something nice here. So we're going to have our x2 is equal to 2 to the power of 2 all over 3. So this is the value of our x2. You can go ahead and substitute that into this place. And when you do that, you see that it will satisfy this challenge here. Okay, so let's take the next one now. So we got to 2 roots as far as this challenge is concerned. So the next one now is this. So here we have our s to the power of 2, then plus our 4 to the power of 1 all over 3x, then plus our 4 all raised to the power of, okay, let's keep this in this format, all raised to the power of 2. This is equal to 0. So here we have a quadratic equation. I want to use the formula method to solve for this. It is pretty easy. So we have our x, our formula says minus b plus minus the square root of our b squared minus 4ac all over 2a. Substituting, what is our b? Our b is this. So we have 4 to the power. So we have a minus here. Okay, so we have minus our 4 to the power of 1 all over 3, then plus minus the square root of our 4 to the power of 1 all over 3 all raised to the power of 2, then minus our 4 times our A is 1, so we have 1 times our C is this. So let's put down our C as 4 to the power of 1 all over 3 all raised to the power of 2. Everything all over 2 times 1. So 2 times 1 will give us 2. All right, so we are almost there. Okay, so let's look at this carefully. We don't have to factor out this, okay? All we just need to do is that what we have here, same thing we have here. So we can factor this out. So doing that, this will give us minus 4 to the power of 1 all over 3, then plus minus the square root of our 4 to the power of 1 all over 3, all raised to the power of 2. If we use this to divide this, we are left with 1. So we're going to have here 1. If we use this to divide this, we are left with our 4 times 1, which is 4. Easy. Everything all over our 2 here. So this is a square root. This is our square. So this can come out. So this is going to give us our x will now be equal to minus 4 to the power of 1 all over 3, then plus minus our 4 to the power of 1 all over 3 to the square root of 1 minus 4. Everything all over our 2. Easy. So if we carry out this expression, this is going to give us our minus 3. And we know that the square root of minus 1 is equal to our iota. So we can write minus 3 as the square root of minus 1 times the square root of 3. And so rewriting this is going to give us, this and this are common. So we can factor this out from here again. So doing that, this is going to give us our minus, and let's still keep this without factoring it out, minus 4 to the power of 1 all over 3, then plus minus 4 to the power of 1 all over 3, then, okay, let's bring in our iota, 3, then all over 2. Okay, so we can still simplify this result down, okay? So we simplify this down, this is going to give us, we're going to have our 2 to the power of 2 all over 3, then in bracket, if we use this, whatever we have here, this expression we have here is the same thing as this. Okay, so if we use this to divide this, we are left with minus 1 plus minus, then this we are left with iota root 3, close bracket, all over our 2 raised to power 1. So we can use this and this to divide out. So if we divide out, this is going to give us our 2, which is, we're dealing with the powers 2 minus 1. So this is going to give us minus 1 all over 2 at the exponent. So let's erase this and continue on this side. All right, so from here, we're going to come up with our 2. Let's separate this. So we're going to come up with our 2 to the power of minus 1 all over 2, then into our minus 1 plus minus iota root 3, close bracket. And so we can shift this down because of this. And so this is going to end up giving us minus, okay, let's just put in the minus straight without putting in bracket. So we're going to have minus 1 plus minus iota root 3, everything all over root 2. But we have to rationalize this. So if we rationalize this, we multiply by root 2. So if we multiply this side by root 2, multiply this side by root 2. So let's just put it down. This all over root 2. Okay? So if we multiply out here, we're going to have our x3. This is going to give us our minus root 2 all over 2. Then plus our, because we're going to have root 2 times root 3 here, so it's going to give us root 6. So we have iota root 6, okay? Then all over 2. And our x4 will give us here minus root 2 all over 2 minus iota root 6 all over 2. So in all, we have 4 roots to this challenge here. 4 solid roots to this challenge, of which 2 of them are imaginary roots, then 2 are real roots. So this brings us to the end of today's math class. You learned something from this video? Put it in the comment section. You have a shorter way, better way of solving this. Drop it in the comment section also. Thank you for being there all the time. See you in our next class. Bye for now.